In this lesson, we're going to look at factorizing a general quadratic expression where the leading coefficient can be any number except for 0. We don't want the leading coefficient to be 0, else we no longer have a quadratic polynomial. To see how factorization works, I am going to look at a product. We have 6x minus 5, 3x plus 2. When we multiply the two factors, 6x times 3x gives you 18x squared. Then we have 6x times 2. That results in 12x. We have negative 5 times 3x. That results in negative 15x. And then we have the product of negative 5 and 2 resulting in negative 10. Upon combining like terms, 12x minus 15x, we end up with negative 3x. So assume that we are given this quadratic and we have no information on the original factorization. While the question is to factorize the quadratic, we want to know what exactly to do. If we can rewrite the middle coefficient of negative 3x as 12x minus 15x, then we can do a 2 by 2 grouping of the polynomial and factor by grouping. Given that we know that the middle term is negative 3x, the question is, how do we rewrite it as 12x minus 15x? Or in other words, how do we know negative 3x should be written as 12x minus 15x so that we can factorize the polynomial? Keep in mind that there are so many ways that you can rewrite negative 3. For example, you can use negative 5 and 2. Where do 12x and negative 15x come from? I want you to notice that when you multiply the leading coefficient with the constant, you end up with the number negative 180. Of course, negative 180 is the product of 12 and negative 15. So we know that there is a relationship between these two coefficients. They happen to multiply to negative 180. At the same time, 12 and negative 15, when combined, give you negative 3. Alright, so what does this mean? When we are factorizing a quadratic like this, we are going to first of all multiply the leading coefficient and the constant. Whatever we get, we look for two numbers, such as these two, that multiply to the product of these two, negative 180, and add up to the middle coefficient of negative 3. Let's look at a few examples. For the first quadratic, we are going to multiply the leading coefficient with the constant coefficient. We have 2 times negative 6, that's negative 12. Therefore, we are going to look for two numbers that when multiplied, they produce negative 12. And when they are added, they give you the middle coefficient of negative 1. The coefficient of x is negative. You could think of a 1 there. When added, we want to get negative 1. 12 has many factors. two of which are 4 and 3. We want one of them to be negative so that the product is negative 12. I would say negative 4 and 3. When multiplied, you get 12, and when added, you get negative 1. What we're going to do is we're going to rewrite this polynomial, leaving the leading term alone. However, we are going to rewrite the middle term using negative 4 and 3. Negative x can be thought of as negative 4x plus 3x. By the way, the order in which you write these does not matter. You can write 3x minus 4x. That's still okay. Negative 6 should be left alone. Now we have two groups. We have a polynomial with 4 terms. We're going to group them 2 by 2. From each group, we're going to take out the GCF. From the first group, we have 2x squared and negative 4x. The GCF of 2 and 4 is 2. And the GCF of x squared and x is x with the smaller exponent. So x, to see what goes inside, we're going to take each of these terms and divide them by 2x. 2x squared divided by 2x leaves you with x. Negative 4x divided by 2x leaves you with negative 2. That takes care of the first group. For the second group, we have 3 and negative 6. They both have a GCF of 3. Open parentheses to see what goes inside the parentheses. You're going to divide each term by 3. 3x divided by 3 leaves you with x. Negative 6 divided by 3 leaves you with negative 2. When you look at this expression, you could see that both groups have a common factor of x minus 2. And that is what you're going to factor out in the next step. Write out x minus 2, open a parenthesis to see what goes inside the parenthesis. You're going to cover x minus 2. That leaves you with 2x. And for the second group, when you cover x minus 2, you're left with positive 3. Let's look at the next quadratic expression. By the way, I should mention that if your expression has a GCF right from the beginning, you take it out. We have 4, 15, 4. They have no common factor. We're going to factor this out using our method. Do 4 times negative 4. That gives you negative 16. Therefore, we're going to look for two numbers that when multiplied, we obtain negative 16, and when added, they add up to the middle coefficient of 15. The two numbers are 16 and negative 1. As you see, 16 times negative 1 is negative 16. When added, you get 15. We are going to rewrite the middle term using these coefficients. Leave the leading term alone. 15x can be written as positive 16x minus 1x. Again, that's our 15x. And then we have the constant of -4. Once again, we have two groups. We're going to take out the GCF of each group. First group consists of 4x squared, 16x. 4 and 16 have a GCF of 4. X squared and x have a GCF of x. So 4x is the GCF of the first group. When taken out, 4x squared divided by 4x leaves us with x. 16x divided by 4x, 16 divided by 4, that leaves us with 4, and x's get cancelled out. For the second group, we have 1 and 4. They do not have a GCF. But as you can see, both terms are negative. So we can take out a -1. Therefore, you're going to divide every term of the second group by -1. Once you do that, both terms become positive. We end up with x plus 4. Just like the last problem, x plus 4 appears in both groups, so we're going to take it out. X plus 4, open parentheses to see what goes inside the parentheses. For the first group, if you cover x plus 4, we're left with 4x. And for the second group, when you cover x plus 4, we're left with -1. There we have our factorization. You can check to see whether or not your factorization is correct. The fastest way to check is to multiply the outer terms. X times -1 is -x. 4 times 4x is 16x. -x plus 16x, in fact, gives us the middle term of positive 15x. Let's finally look at the last example. We have a trinomial. It's not a quadratic because the degree is 4. But as I said, for every expression, we're going to look for the GCF of all the terms. We have 33 and -6. They're all divisible by 3, and 3 happens to be the largest number that can divide everything. So the GCF of the coefficients is 3. For the variable factors, we have x to the 4, x cubed, and x squared. X squared is the GCF of the variable factors. Remember, x to the smallest exponent is the GCF. To see what goes inside, you take every term, divide by GCF. 30 divided by 3 is 10. We have x to the 4 divided by x squared. That's x squared. Next term, we have 3x cubed divided by 3x squared. 3's get cancelled out. X cubed divided by x squared is x. We are left with x. You can just think of that as 1x. For the last term, -6x squared divided by 3x squared. -6 divided by 3 is -2. I already have the negative. X squared divided by x squared leaves you with 1. Basically, x squared has been placed outside. So here we have a quadratic that we want to factor out. Given that it's factorable, you multiply once again 10 and -2 to obtain -20. Therefore, we're going to look for two numbers. When multiplied, we get -20. And when added, we get the middle coefficient of +1. So I hope that you all can think of what these numbers are. Let's say -4 and 5. They multiply to 20. -4 plus 5 is 1. Again, the order of writing doesn't matter. I could write 5 and then -4. It doesn't make any difference. To factor out our quadratic, we are going to carry down the GCF. 3x squared. Open bracket or parentheses. Leave the first or the leading term alone. -1x is going to be rewritten using these two coefficients. We can write 1x as -4x plus 5x, or 5x minus 4x. It doesn't make any difference. Once again, we have 4 terms, groups of 2. From each group, take out the GCF. And don't forget that every time you have to copy down the original GCF. From the first group, we have coefficients 10 and 4. They both have greatest common factor of 2. X squared and x have greatest common factor x. To see what we get inside the parentheses, again, divide 10x squared by 2x. That leaves you with 5x. -4x divided by 2x is -2. For the second group, notice that there is absolutely nothing in common. We have 5x and 2. Those coefficients have no GCF other than 1. Therefore, I'm going to write out +1, open parentheses, 5x minus 2, because 5x divided by 1 is 5x. -2 divided by 1 is -2. Close the bracket, or if you open parentheses in the beginning, close the parentheses. Carry down the original GCF, and we are ready to factor out what's inside the bracket. Inside the bracket, we have 5x minus 2 in common. We're going to take that out. When you take 5x minus 2 out from the first group, we're left with 2x. And from the second group, when taken out, we're left with +1. You notice I have pretty much dropped the bracket. It's unnecessary. And that's because we have now the product of factors.